మార్నింగ్ సార్ జూమ్ లో ఒక ఇది పెట్టాలి. Hello, good morning everyone. We are here to conduct an exam class on vector differential calculus. My name is Mohammad Mustaq Ali. So here the topics are in the vector differential calculus. We are going to cover here are scalar and vector point function, gradient, directional derivative, divergence, curl, physical interpretation of operators. These topics we are going to cover here. Now, this is first one. What about this is unit vectors. Unit vectors, as we know that I bar, j bar, k bar are the unit vectors, and the value of I bar is in the three-dimensional xyz space. The value is 1 0 0. The point 0 1 0 is j bar, and the k bar is 0 0 1. Next, the position vector is, we have here r bar equal to xyz, the position vector in the three-dimensional. So it can be write as xi bar, yj bar, zk bar, and r equal to, from the r bar we can write it as modulus of r bar. It is read as magnitude of r bar. The magnitude of r bar is under square root x square plus y square plus z square. Here the unit vector of r is equal to r bar by r. That gives us the required unit vector of the position vector. So here dr bar equal to dxi bar, dyj bar, dzk bar. R bar equal to, as we know that, xyz, and this can be split into the three parts as like this: xi bar, yj bar, zk bar. You can see here x100, y010, z001. So here next point is scalar point function. The difference between the scalar and vector is here vector point function, the magnitude of the direction and the magnitude. Scalar point function has only magnitude. Sir, here sir, కొంచెం స్లోగా. Here sir, కొంచెం slow. Scalar point function, it has scalar point function means f maps r cube to r. It is defined as. Now here explanation of the scalar point function is only that it has magnitude only, no direction. If it has direction, it is called as vector point function. So that is the difference, simple difference between the scalar and the vector point functions. So here you can see that f maps r cube to r. R cube means triplet xyz, order pair, pair of xyz. Okay, xyz. F of xyz equal to, here given function as x square plus y square plus 3xyz. It is scalar value, only scalar, without any directions. Vector point function here, f bar xyz equal to f1 xyz I bar, f2 xyz j bar, f3 xyz k, where these f1, f2, f3s are scalar point functions. So here x square I bar plus y minus yz j bar plus 2xyz cube k bar is our example for the vector point function. Vector operator. So first operator in the vector calculus we have here del. Del is equal to sum of I bar dou by dou x. So here sum means these I j k terms, I bar dou by dou x plus j bar dou by dou y and k bar dou by dou z. It is called the vector operator del. Okay, next look at here the two normal vectors and different types of normal vectors here given. So it is a polygon and it's two normal vectors with the two normal vectors. A polygon means a two-dimensional face. It is a normal to a surface at a point is the same as a normal to the tangent plane. It is a plane given here at the surface in a simple point. A curved surface, polygon, and a plane and a curved surface is given here. So the curved surface is showing the unit normal vectors to the surface here. Okay. So the blue arrows are the unit normal vectors here given. You can observe that. Okay. Next. Next we have here simple explanation about the normal vectors of the square and means plane, and it is a circle and a hyperbola. So here you can see that ax plus by plus cz equal to d n bar of the unit normal vector of the plane is n bar, unit normal vector n bar by magnitude of n bar. Similarly, for the circle or sphere, x square plus y square plus z square equal to r square is a sphere equation which is passing through the horizon. So here n bar n cap equal to xi bar plus yj bar plus zk bar by r. As we know that r values, x to z equal to x square plus y square, it is a hyperbola equation. Gradient of a scalar point function. From the given vector operator, first operator del, if we operate this del on any scalar point function, then we obtained del f. So that is called the gradient of the given scalar point function. So grad f equal to del f. So I bar dou by dou x, del means as we know that I bar dou by dou x, j bar dou by dou y plus k bar dou by dou z into f. So this is called our gradient del into f. So that gives us I bar dou f by dou x plus j bar dou f by dou y plus dou bar k bar dou f by dou z. So this is our gradient of a scalar point function. Okay. So what is this gradient? The geometric interpretation of this gradient is grad f is a normal vector to the surface. Simply, what is the geometrical interpretation of this gradient is, if it is a given surface, it's a normal vector. F is a function, and function means it is a surface, given surface, and it's a normal vector is our gradient. Gradient gives us our normal vector of the given surface. Yeah. So unit normal vector to the surface is equal to n bar n cap equal to del f by magnitude of del. Next one is directional derivative. Directional derivative obtained from the vector. So here the directional derivative of f of xyz in the direction of vector a bar is, here the direction of the vector is given in the vector, the direction of vector a bar is df a bar equal to del f dot a bar by magnitude of a bar. df, here capital D stands for directional derivative of f, and we write a bar in the suffix as suffix of f. It means that it is in the direction of a bar. So df a bar equal to del f dot a bar by magnitude of a bar. So del f dot unit normal vector of a bar, you can write that also. So here del f dot a bar by magnitude of a bar is the maximum in the direction of normal, and its value is magnitude of del f. So in the direction of directional derivative is the maximum value in the direction of normal, and its value is del f. Okay, next one. So here you can see here what is the directional derivative. What is the in the direction, in which direction we can get maximum value. So here you can see this a balloon in the direction of line, red straw indicates the normal vector, and the black straw indicates the given direction. So in which direction we can get the maximum? In the normal direction, normal vector direction only. So you can see here, we get that the graph f of x, y, z 10, 20, 30, 40, 50. So we can get maximum value in the direction of normal vector. So this is the properties of simple properties of gradient we have here. That is, those are del f of f plus or minus g. This is linearity property. Del f plus or minus del g, del f g, as like as our in the derivatives using the UV method, like that f del g plus g del f, as like as the u by v formula here, del of f by g, g del f minus f del g by g square. Del fn is equal to del f nth derivative here, as like as in our direction, simple direction derivative formulas, n fn minus 1 del f. Same properties as like as our derivatives. It is also satisfies all partial derivatives formulas. Okay. It's like partial derivative formulas. So here, let us see one problem on this topic. Find grad f where f is equal to x square y cube plus 2yz. Okay. So dou f by dou x equal to 2xy cube. Here, differentiation with respect to x, first of all, x square y cube plus 2yz. Here we are practicing the partial derivative. So partial derivative with respect to x, then we treat y and z as constants. So in that case, y cube is a constant here. So x square derivative 2x. So what we get? 2x y cube here. So plus 2yz. Second term is 2yz. Here practicing the partial differentiation with respect to x, so y and z becomes as constants and their constant derivative, generally the constant derivative is 0. So dou f by dou x value we obtained as 2xy cube plus dou f by dou y. The dou f by dou y equal to 3x square y square plus 2z. How we obtain this? Same formula. We are practicing partial derivative with respect to y here. X and z treat as constants. So x square constant, y cube derivative 3y square plus 2yz, 2z into y derivative 1. So 3x square y square plus 2z is our required dou f by dou y. Similarly, dou f by dou z obtained as 2y. Okay. First term x square y cube is constant, constant derivative 0. 2y constant into z derivative 1. So 2y. Grad f equal to, as we know that the formula I bar dou f by dou x plus j bar dou f by dou y plus k bar dou f by dou z is our gradient f formula. So like, let us substitute those values dou f by dou x, dou f by dou y and dou f by dou z in the gradient f. Then we get our required gradient f value. So I bar dou f by dou x value 2xy cube plus j bar dou f by dou y value 3x square y square plus 2z plus dou f by dou z value 2y k bar. So here this is our required gradient. Yeah. Okay. Thank you. Did you all understand? Any doubts regarding this? Okay. Thank you. Next, continuation about this. This is about the unit normal vector to the surface. You can find it by using the same formula. First of all, you have to find del f and magnitude of del f. How we get the magnitude unit normal vector? Del f by magnitude of del f gives us the required unit normal vector of the given surface at the given point 1, 2, minus. We have to substitute the 1, 2, minus 1 for xyz values at the end of the problem. Then you get required unit normal vector. So by using this del f, you can find, that means it is easy to find the angle between the surfaces, by using this normal vector. What is the normal vector here? Unit normal vector is gradient of the given surface. So by using this normal vector, you can find the required angle between the surfaces. So here, what is the general formula for the angle between the surfaces? Suppose theta is the angle then cos theta equal to del f dot del g by magnitude of del f and magnitude of del g. So where del f and g are both given two surfaces, we have to find the angle between these two surfaces. So the cos theta equal to here del f dot del g by magnitude of del f by magnitude of del g. The angle between the surfaces is equal to the angle between the normals. So we find the angle between the normals so that we get this. Okay. Next point is we have here divergence of a vector point function, gradient and vector point function. Gradient is applied del on the scalar point function. Same del we are applying here on the vector point function, that is called divergence. Divergence of the vector point function. Del dot. Here clearly mentioned two products here we have in the vector point function, that is dot and cross. Both are different. So here applying the del and f, in between these we are applying the dot product. So del dot f bar is equal to del I bar dou by dou x, j bar dou by dou y, k bar dou by dou z is our del value dot f bar value. Suppose that f1 I bar, f2 j bar, f3 k bar. Then this product of these two, what is that? As we know that the product of two same vectors like I bar dot I bar equal to 1 and I bar dot j bar and I bar dot k bar is equal to 0. So using that condition, the formulas here, dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z is our required divergence of the given vector point function f bar. Okay. So here you can see that what is the difference between the formula gradient f equal to del f, as we know that, and the divergence f bar is equal to 0, then f bar is said to be solenoid. Here you can see that mistake and blender mistake. What is the mistake and what is the blender mistake? You can equate two integers which are equal or not equal, that is called mistake. If you equate integer or number with any sign, any algebraic values like plus, into, minus, and so on, these are called blender mistakes. So here remember that writing the values in correct mode, otherwise it may be mistakes. Next, divergence f bar. If divergence f bar is equal to 0, then that f bar is called solenoidal vector. Solenoidal vector. Okay. This is del dot f bar is not equal to f bar dot del. Okay. Next operator, same operator, we are applying del on the vector point function with the cross product, applying the cross product in between them, that is called curl simply. If we apply del f bar in between them, we apply the operator dot, that is dot product, applying dot product, then it is called divergence. If we apply cross product, that is called curl of a vector point. So curl f bar is equal to del cross f bar is equal to, the formula is determinant of ijk dou by dou x, dou by dou y, dou by dou z, and f1, f2, f3. So this is our required curl f bar formula here. So here also one point we have here, curl f bar is equal to 0, then it is called f bar is said to be rotational or conservative. Okay. The function phi is called scalar potential of f bar if grad phi equal to f bar. If gradient phi is equal to f bar, then that phi is called the scalar potential of the vector point function. Okay. Next. Physical interpretation of divergence. What is physical interpretation of divergence? If V bar represent a physical quantity like heat flux, electric flux, and so on, then the scalar divergence V bar gives the issuing of V bar at a point per unit volume in unit time. Okay, look at this. In the dot, in the direction of dot, in the opposite direction of dot, and in the reverse, some other direction of the dot product here, del dot V bar less than 0, del dot V bar greater than 0, del dot V bar is equal to 0. The direction of the vector depends the divergence value. Is it less than 0, greater than 0, or equal to 0? Okay. If divergence V bar equal to 0, as we said that already, this is V bar is said to be solenoidal. You can see here, I will play this, you can see that clearly. Next point is physical interpretation of curl. What is the physical interpretation of curl here? Consider a rigid body is rotating about a fixed axis. If V bar is the velocity of any point of the body, then and some symbol omega is the angular velocity, then 1 by 2 curl V bar. And angular velocity is 1 by 2 curl V bar. So here this is angular velocity gives the curl of the vector point function. Okay. If curl F bar or curl V bar is equal to 0, then V bar is said to be irrotational, or otherwise it is said to be rotational. Okay. Laplacian operator here. We have here Laplacian operator del square, dou square by dou x square, dou square by dou y square plus dou square by dou z. Del square f equal to 0, then f is said to be harmonic function. It is said to be harmonic function. These are some problems on this topic we have here. Thank you very much.